Cool. Let's get my slides up there. Perfect. Let me quickly get ready. Thank you guys so much for coming to my talk. This talk is on scalable distributed messaging with Kafka on containers. We'll be talking a little about Kubernetes as well. But my name is Claudius Mbemba, and if you have trouble pronouncing my last name, there's a quick trick there. The first B is silent, so you should pretty much get it after that. So just a quick intro about myself. I'm an ex-Microsoft engineer and current CTO at New. New is a platform connecting Airbnb hosts with local cleaners who can clean the place before guests check in. We're currently in market in Seattle and expanding to other markets here soon. But you can follow me on Twitter at memberships, my website, and the following GitHub handles. So what we'll cover today is a problem we recently faced at New, the solution we built, do a quick demo, and then we'll conclude. So at New, we're building, again, a platform. And so we're built on Kubernetes on AWS, leveraging microservice architecture. And so we had this problem that we wanted to introduce real-time communications, real-time notifications for users into our platform. And so we knew we wanted to use a pub sub mechanism, and so we started searching online to find open source mechanisms because we didn't want to build one out of the gate. There are tons of open source pub sub tooling out there, and we're like, there's got to be one we could use. We researched and found a bunch of open source tooling, but none of them really kind of met our criteria. There was always some type of issue, whether it was the library is no longer being maintained by the creator, the library has outdated core dependencies, running a basic hello world sample fails from the box, or the kicker for us was really offline persistence. We needed a library that allowed for users to be able to, once they log off, when they come back, see the messages that they had accumulated during the time they logged off. And so the offline persistence was a key one that we couldn't find in any of the open source libraries we looked at. And I don't have time to go into all the libraries we looked at, but I'm happy to chat with anyone after this talk about the ones we explored. And so realizing that there wasn't a solution for us, we came to one realization that we needed to write our own solution. And so from the get-go, I don't advise anyone, again, like I mentioned, there's tons of great open source solutions out there. I don't advise you guys to go start by trying to write your own solution. Leverage the open source community. I know you guys are JS developers, so you already do that, but definitely take advantage of that. But we started to theorize what technologies we could put together to create this system. As I mentioned, it needed to be real time. We had a couple of requirements given that we were built on Kubernetes and using microservices. So it needed to be able to deploy on containers so it could be on the cluster as well as handle scale. So the team and I theorized about the technology we could use, and we settled on a couple: Node, which was our language of choice, Kafka for Apache Kafka for the messaging processing, and WebSockets for the real-time communications. So this talk again is going to anchor on Kafka with some topics on Kubernetes and WebSockets sprinkled in there, but I'm mostly going to be focused on Kafka. Just a quick show of hands here. Who has heard of Kafka before? Great, a good amount. Now, who's actually used Kafka before? Even less. Yeah, that's what I expected. So we went on this journey of kind of exploring how do we leverage Kafka in our system, and what's Kafka good for. So just a quick, as you can see here, this image kind of gives you a basic overview of Kafka. It's a distributed streaming platform, but what does that really mean? So this definition is taken from the Kafka.org website. Kafka is used for building real-time data streaming pipelines, apps. It's horizontally scalable, fast, and runs in production. That runs in production is really key, as you'll hear about in a few, because Kafka is being used by some major companies. But in a nutshell, Kafka is a highly available central hub for message processing. It works as a distributed commit log where data comes in, is available to retrieve, but it's also stored in that commit log. It's different than most other messaging system, like MQ, which are just queues, so once the data is off, you can't really get it back. It's highly available, highly tolerant, and highly scalable because you can do all the message processing on the back end, so it allows your client to be thin and easy to run. So there's a lot of topics in Kafka, and so I'm going to use a simple analogy to kind of get you in the mind frame. So if you think of Kafka, this is how I like to think about it. If you think of Kafka as a post office, then you have producers, which are senders, consumers, which are receivers, and there's this concept of a topic. I like to think of a topic as the big P.O. box wall when you walk into the post office, which has partitions, which are the individual P.O. boxes, that essentially let you manage your mail, which is your messages. So hopefully you guys kind of, from that analogy, get what Kafka is. And if you didn't, here's a quick image to kind of drive that concept of the topic home. Again, you have partitions, you write to the end of the partition, and you can read from any offset there. So Kafka, like I mentioned, runs in production, and so it's being used by a ton of big name companies. I'm not going to list them. I'm not going to read them all here. You can see those logos. I'm sure you recognize a bunch of them. But two I want to call out, LinkedIn and Netflix, both leverage Kafka to handle and process over 4 trillion messages a day. Kafka was actually built at LinkedIn by the engineers there to handle their scale problems, and it was then open sourced and made available for the community to take advantage of. And again, tons of companies have then tapped into the power of this central processing hub to build their applications for scale. And so that's what we sought to do at New and in our platform as well. Again, Kafka is a central hub for message processing. You've got producers writing into your hub, consumers subscribing and listening to messages from the hub, and there's a concept that you can actually group consumers into what's called a consumer group for faster processing and parallelization of message processing. So let's get back to the story. Now that you guys have a framework for what Kafka is, let's get back to the story. Now that we knew we were going to use Kafka, we had to figure out a library that could help us essentially talk to Kafka using our preferred language of choice. And so we did some research. We found 2 open source libraries that were very popular. We ended up going with the Kafka node library due to community support and its popularity. And so next, we had to figure out how do we get Kafka into our cluster. And so again, I told you we had that requirement for scalability. We needed to put it on containers and figure out how do we get that into our cluster. And so we did a little more digging, found that there's an open source containerized Kafka image. And so we leveraged this Docker image, Kafka Docker, to be able to create instances of a Kafka broker, so it simulates on more or less containers, multiple brokers in that image I showed earlier that you can then use as your central hub. So we're able to get that deployed in our Kubernetes environment, and because it runs on containers, it's great because you can run it locally as well. And I'll show you guys that here in a few. And lastly, I mentioned we needed real-time communications, and so again, this talk is not on WebSockets, but hopefully you guys are well aware of it if you look in the far right there. WebSockets, we use WebSockets for real-time bidirectional communication from the server to the client. What we did was we created a container for, we created a socket client container that leverages WebSockets, deployed it to our backend server, used an AWS L4 load balancer to serve traffic to that container, and then on the client side, we're connecting directly to that socket endpoint, so that socket load balancer for communication on the backend. So that was our implementation for WebSockets. So the solution, all of that together is what we came up with the final solution. This library called Kafka Pub Stuff that we wrote. It is a durable wrapper around Kafka node and the calls, and the Kafka function calls to make it more pub sub, make the calls more the function calls more pub sub friendly. And so in it, there you can instantiate a producer, and that could be a high-level producer or a regular producer. So again, Kafka node has lots of different concepts. We try to abstract a lot of that from you, and we built this library for scale, so I'll explain really quickly. High-level producers produce messages in a round-robin basis across your different partitions, so allows for even distribution across your different partitions. Whereas a regular producer, you have to specify the partition that the data goes to. So high-level producer, you can think of it as use that for scale, and then regular producer, use it for any other instance. So you can init producer, send messages, and then you can also instantiate a consumer or a consumer group. I mentioned earlier, consumer groups are used for parallel processing as well, so that's another scale piece for Kafka. If you want to scale, use consumer groups versus a regular consumer. And so you, by default, also get with this library, that offline persistence that I mentioned, again, being key, you want to be able to, offline persistence is when the user can log off, come back, and retrieve the messages that they last left off at. And I'll do a demo of that so you guys can kind of see what that looks like using Kafka. So really quickly, to do a code walkthrough of our library, this is the, here we're setting up our cluster. So these are a 3-node cluster, passing the different endpoints, creating a topic using the user's email, instantiating a consumer, listening with that consumer, and then creating a producer that produces messages on an interval of every 5 seconds. You can see here just writing a date time. And so this is a same code using the high-level or scale bits of that library, again, the high-level producer and the consumer groups. You can see here that we're still instantiating a topic, creating our topic options, which includes the partitions and the replication factor. So again, I mentioned Kafka will replicate your data and keep it highly available for you. So 10 partitions per topic, and that partition can be replicated 3 times across each node. So each node has up-to-date data. We're instantiating a consumer group, again, for scalable message processing, listening for that, on that topic, and then creating a high-level producer, which will produce messages evenly distributed across the different partitions, which we have 10 of, and so then we can listen to those messages. And that's also going on interval. So really quickly, we're going to do a live demo, and we're going to first run Kafka on localhost, and then show you an instance of running the single producer consumer and showing you the offline persistence piece, and then lastly, running scaled Kafka on containers. So let's dive into it really quickly. So I have here, at the end, you guys will get links to all this code, but I have here really quickly an instance of a producer consumer. You can see here using Kafka node, and let me quickly show you that we are already running, hopefully you guys can see that. We're already running an instance of Kafka. Again, all the documentation is on this code, so I'll send you guys the link here. We're running instances of Kafka, so we have one broker, and that's just one broker. So gonna quickly start our producer, which will start producing messages to our hub. And then you can see here, this is hello is the topic. This is our partition that we're sending messages to, so we're always sending messages to partition 0. And then this is the offset that the messages are coming into. So we started our producer. I'm going to then start our consumer. And really quickly, you can see that we logged, more or less the consumer logged in. You can think of that as a receiver coming in to pick up their mail. They're getting their mail as it's coming in. But let's say that the receiver decides to log off for the day. And you can just see really quickly the message, the topic, hello, the value, which is just date time, and then the offsets. But again, let's say that the consumer decides to log off, so I'm just going to close that. Really quickly, let me make sure we logged off at offset 18, just to keep that in mind. So again, simulating that the consumer is logged off, messages are still coming into the system. So this is being offline, but something is still sending you notifications, more or less. We're up to 30 by now, so let me log back on really quickly, so before we get too far. Let's see here. And so we got to scroll up, but if you see here, we picked off messages from pretty much where we last left off. I think so it's picking up messages from essentially where you last left off. You can see here we're committing that we've received this message, and so the system is keeping that in track. And you can also program in there where you want to pick up from a different offset. You can also program in that. So that is, again, that is a single broker running a producer, consumer, and getting offline persistence. Really quickly, I wanted to show running a scaled broker. I've got some code here that I want to run. Let's see. So we're using Docker Compose to run all this locally. Again, we're still using the Kafka Docker image. So I'm just going to paste this code and run a 3-node cluster, again, simulate a 3-node cluster on localhost. It's going to kill my initial Kafka 1 and then create 1, 2, and 3. And so just really quickly, let me see here, Docker PS, showing you, well, or not. We'll try this one more time and then see if that worked. What you should see is that there's 3 instances of Kafka. I only see 2 so far, so something went wrong in Docker creating those instances for us. But no, there we go, perfect. So we have Kafka 1, 2, and 3, and so we now have that single broker scaled to multiple brokers, so more or less running multiple containers of that service. And again, Kafka is a clustered hub, so all these brokers are talking together, talking in terms of replication factor. So if I send a message to 1, it gets replicated across 2 and 3. And so that is that. Let's get back to our slides. So that's the end of the demo. I wanted to quickly wrap up on what we've kind of done here. We've, again, shown you guys what Kafka is, what it's capable of doing, again, being a central hub for all your communications. And what I think is lost on people is that we've moved from this, central hubs to distributed everything. And so people, when they think of Kafka as being a central hub, they're asking, oh wait, can't this be one failure point for my whole system? But if you realize Kafka is, again, you want to deploy it as a cluster so that it's highly available. And Kafka, if you think about it in the sense of if you work with Kubernetes, you want to have replication, so you want to have multiple masters or multiple brokers that will then persist your data so that it's, there's no one single failure point. Unless your whole cluster goes down, then there's a single failure point. But that's any software. So that's our story. That's what we built it new. Really quickly, again, we covered the problem of needing to build a notification system. Not really finding any suitable solutions. Again, the offline persistence was a key piece. Having to cobble together the 3 technologies of Node, Kafka on containers, and WebSockets to build a system that worked for our scale. And we did a demo. So again, you can find this library on our GitHub, GitHub/new-cleans Kafka Pub Stuff. A couple resources and takeaways for those of you who are interested in learning more about Kafka. You can see here, there's a really good podcast with one of the co-creators and the current CTO of Microsoft. And then Kafka tutorials, these slides will be available online as well. I'll show you in the next one, but if you want to take a photo, go ahead and take a photo. ApacheKafka.org is a good resource as well to learn more about Kafka. And last but not least, again, all of this code that I showed, again, we've got our library, we've got our socket.io sample. This socket.io sample was something I was going to show, but didn't get to it because as I was testing it out today, the demo kept failing, and so demo gods weren't on my side today. So fortunately, I did not get to showcase that, but you can find the code there. Essentially, what that does is using that 3-node Kafka cluster that we set up last with our scaled brokers, you can then create more or less this sample simulates users logging in and sending messages to a specific channel using sockets, rooms, socket clients, rooms feature that essentially allows you to limit the messages to, or segment the messages coming in for a specific client ID to just that one room. So making sure that the messages aren't, one user's messages aren't going to a different user, essentially. So you can check out that sample there. I can, more than happy to chat more about it after the talk. And then this is a link to the investigation we did around PubSub, the different samples and open source solutions we checked out and tried before settling on building our own kind of wrapper around these 3 technologies. Yeah, so that is my talk, and thankful for you guys coming out. Hopefully you guys are awake after having some coffee. We've got some other great talks here, and so that is it. Thank you guys so much.